Yeah, it started. Yes, let's start.
Yeah. Yeah. So our first problem is like sequential digits. An integer as a sequential digits if and only if each digit in the number is one more than the previous one, and you have to return the sorted list of all the integers in the range low to high. So you're like from 100 to 200, you have 123. So 1 plus 1, 2 plus 1, 3. I mean, the digits in that number are in one greater than the previous one. So these are the numbers falling in that, and results should be sorted. Same goes for this. And constraints are like your high will go up to 10 raised to over 9 and low is 10. Yeah. So what should be brute force?
Brute
Should
force
generate.
is,
Yeah.
sorry, good.
I'm saying generate all the possible numbers, right, from 100 to 300, and then just check the given condition for each number.
Right, right. Generate any numbers from the low, yeah, till the high. All the numbers, right? And then just
Yeah,
check for
yeah,
the condition. Correct. Yeah. So take the first one, something like 1, 2, 3, and then keep on looking for the next one. Yeah. Yeah.
yeah.
That's one way of doing it. Yeah, absolutely. So what are the, what do you think?
Backtracking also we can use, right?
Mm-hmm.
Backtracking, let's say we'll start from 1, right? And now when I go to 2, I'll check. No, quite too good. I mean, from here I'll start. I'll go first put 1. Now the next number should be 1 greater than this. So I'll
Mm-hmm.
put 2 here, right? And on the same, while doing all these things, we'll also check that the given number form should be less than 300.
Mm-hmm.
And then 2 plus 1, 3. Now let's say if I try to put 4, but it is exceeding our limit, I mean more than 3, so we'll backtrack from here. And then we'll go for next number. We'll start with 2, then 3, and then 4. 5 you can't go. But again, when you take 3, 3 is correct. I mean, right, first digit. But 4 is not allowed because it will cross your this, right?
Mm-hmm.
Second digit it will cross. So you'll again backtrack from here.
Yeah, I think makes sense. Yeah.
But we have similar problem where they say 1 plus 9, something like that. I mean, the difference between two consecutive digits should be 9 or 7, something like that.
Okay. Uh-huh.
Yeah, so based on that strategy, if we,
Okay. Yeah. That would work. Yeah, absolutely. Then you memorize it a top-down approach. Yeah.
yeah, memorize it.
I did
Because
try it that way, but yeah, I think the way you are describing, yeah, should not be a problem to implement, right?
yeah, we have solved actually one problem with this logic only. I mean, I don't remember the number, but
Mm-hmm.
I'll
Okay.
share one circle here.
Okay.
When you do the backtracking, that
Yeah,
would be the result would be uh, sorted, or right. You don't need to do additional it, step to make the result sorted.
yeah, looks like that, but it need not be, right. Uh,
Uh,
how will you? Let's say 1 you put here, then 2 you will put here. You'll have to take something you'll have to take care so that the numbers from these should be sorted, right? Because I can pick this number also first 3 and then 4 and then 5. But how will you make sure it should be sorted?
No, actually, what we can do is, the first
Yeah.
number, whatever we start with, we should
Okay.
have that number as a parameter to our one of our recursive function. And so whatever number we are forming, it should be based on that number. Okay. So
I
first
plus
we
1.
start with low 100, right? And then
Yeah.
when we are forming the next one, it should be 1, 2, 3. Okay. So then
Yeah.
we are done with it. We put in our result list. Okay. Then we are again coming back. We should use this number 1, 2, 3 as our base for the next number. Okay.
Okay. Or take the first digit only of that number, 1, because next number will always start from 2 only, right? If
So
it is in a sort.
if it is just a first digit, then you will keep on forming the 123 over and over again, right? So you'll have to form something greater than that. So that will be a reference.
No, I plus 1 I'll take. When I extracted 1, I'll put here I plus 1.
Yeah, there are several ways to do it. But yeah, but this is one of the way I was thinking. Yeah, just thinking loud. So
Yeah, sure.
yeah.
So you do like 1, and then you plus 1, 2, and plus 1, 3, right? Then
Yeah.
when you backtrack, you when you backtrack, you always have to backtrack to the beginning, right? Because the next number have to begin with 2.
No, one for loop will be outer for loop, which will take care of the sorted ones. Like first number will be 1 followed by 2, and inside that one for loop will be there to fill this parallelly. Like this is one, then J will run. J will check I plus 1 is in a valid range or not. If it is, we'll put it. Then J will increase 3. Now once J is less than 3, less than equal to 3, we are done. So we'll backtrack from here, and then I equal to 2 will run. So this one.
Yeah.
Again, J will start from here.
So you always, yeah, in this case, I don't know if that's a backtracking or not, because it always always start at the first number. You cannot start somewhere in the middle, right?
Yeah.
Yeah.
That's true.
So what you can do is you can take a for loop in your main function,
Okay.
and then you have a recursive function in that for loop. So you always start with the digit from whatever 1 to 9. So because every time the first digit will keep on changing, right?
Yeah.
So that you take as a seeding for the recursive function, and then keep on building it and come back again to this main for loop, and then start with the next one. So you don't do backtrack or something like that. Whenever you find a number, you just return from there.
At that point only.
The
Yeah,
window,
then that might be one way if that is a thing to solve, right?
So in this case, the low is okay, yeah, got it. So low and high could have different. High could have different number of digits than low, right? Yeah, see example 2 here.
Yeah, so yeah, that will be tons of challenges there also. Yeah, I got your point, because if the low also has many digits in it, so then how do we take care of it, right? Yeah,
So
but
in case of like Shashank do, so in what how would you handle when low have like 4 digit and high have 5 digit, like example 2?
Yeah. Then okay. So that is whenever what you say. This is a good point, right? If we have desert.
okay, in that case, then you'll have to take, see, like low and high. Okay, you'll have to compare how many digits both of them have. So you'll have to say in this case, low's first digit is 1, okay, and the high's last digit is 13. So you will have to run a loop like that from 1 to 13, okay, at the top loop.
Okay.
Yeah,
To
and
do
then
it.
always say that the number will be at least 4 digit, and if it is 13 or when it crosses at 10, it should be a 5
To
digit.
do.
Yeah, one more, yes. And
Mhm.
so some
Yeah.
dirty tricks you'll have to.
I didn't think about that. I thought that both are of three digits. It's a good point.
Yeah, me too. Actually, I was not thinking, but then when he said, yeah, makes sense. It's a good observation.
So
Or
after
like
the
in this
yeah.
case, let look at example 2. We see that low have 4 digit, right? So high would need to have 4 digit too, initially, and then the upper high would be, in this case would be 5 digit, right? So if we try with all the low, would begin, I mean, with 4 digit first. For example, look at the output. We try 1, 2, 3, 4, 5. All have 4 digit. Then we run out 4 digit. We start with a 5 digit, right? Like 1, 2, 3, 4, 5, and we keep going.
So you can cache it also, right? 1, 2, 3, 4, and then for the 5, simply the previous result what you have obtained.
Oh yeah, you can do it too.
DFS with cache.
Yeah, not a problem. I think that should surely work. Okay, So if not, then what are the better ways of doing it? Yeah,
One
I
is
think that
like,
is also an optimized way. Yeah, yeah.
and
Only I didn't try it, so yeah.
no,
Okay.
I just remembered long back we did it that, so it came
Mhm.
now.
No, it's a good thing.
There
We
is,
can try it later, when
yeah,
we are done
definitely.
with the session. Yeah.
And we don't need to sort also in this case, right?
Right,
I'm
right,
not
right.
sure.
Because that's the way we are generating. It will always be in a sorted form. Yeah, but they are not saying we have to return in sorted form, but usually it is all, oh yeah, return a
Sorted
sorted
it
list.
should.
Yeah,
Yeah,
okay. Mhm.
they mentioned.
Okay, okay. So then how would we go about a better way of doing, or
Better
maybe?
way just what I would, it's like you go from 1 to 10 and just check as long as the number which you are forming, if it is lesser than high, right?
Mm-hmm.
That is the outer while loop. And inner just you check whether it is satisfying that condition or not. Next digit is greater than the previous one.
Mm-hmm.
I mean, code will make it more clear. Yeah. So this is what I'm doing here.
Mm-hmm.
So I'm going from 1 to 10, right? Initially, my current number and next and is equal to digit only 1. Now this is that condition. As long as the number you got, if that is less than high, and next number should always be less than 10, right? So here is checking if your number is greater than low, we are appending it to our this, and next we are increasing by 1, because that will be that is the condition. Like next digit should be greater than the previous one, right? Because both next and num are starting from 1 initially, and
Okay.
whatever you got next, you just num into 10 plus next.
Okay. So every digit wise you are incrementing,
Yeah,
and then you are putting this here. Okay.
forming
Mm-hmm.
the number. But this will hit TL in some other languages, I think, right? Or
Mm, why it should do that?
because
Why it will be a tail?
we are forming that number. Integer can be very big. Then in that case, I'm not sure. Like,
But we are always forming a next greater number, right? The way the rule is saying, correct?
yeah,
So we are not forming all the numbers. So I don't think so. It should
then
hit it really, right? So the inner loop is actually taking care of forming the, like in this example too, if the starting point was 1000, so
yeah.
the inner loop is going to form the first number as 1, 2, 3, 4, the way I understand your code.
Mm. But
Yeah.
the inner loop, it always start at 1, right? But let's say the lower is somewhere higher. So we always start at 1. Right? Let's say suppose that you want to find a number, between 299, maybe 200 to 300. For example, but you always start at 1, right?
Yeah. No, but
We
the
guard
next is also
against the high, but we don't guard against the low.
Yeah. So in that case, actually, you could modify the line number 5, something like that, right? So you can make it equal to at least low. So that condition, what Leon's saying, maybe a slight optimization on it. I just thinking loud in this case also,
Yeah.
right? Yeah. Then it will be more efficient, or maybe whatever the block you are talking about will be undone there. Yeah. Yeah, but this is also good, right? So you just keep on incrementing the next digits. So yeah,
and you keep on forming the numbers.
yeah. So there is one more way of doing, right? If we can use a BFS way,
Oh,
right?
yeah.
So in the BFS, what we do is we start with a queue, and in the queue we push in all the numbers. Okay, let
Yeah,
me
yeah.
share that. So the way I did was,
Yeah, I remember the same process you told there also. In that problem also, 7, you are putting it in a queue.
oh really? Okay.
Yeah, I
Maybe
yeah.
then I just copied that one, that solution here. You never know. Yeah. So this is what. You push in all your digits 1 to 9 in the queue, and then this is our queue. You take any value, okay, and then you keep on incrementing this one, right? So you'll always find your V should be between low and high. You push in that. If it is greater than high, you break. But this is where actually the next number is formed.
And again putting back
Yeah.
to queue.
Yeah, but in this case, it's like you're starting from again from 1 to 9, and then second after you get 1, you put the next one will be 12, right?
There,
So you're updating to the 12, and then you're pushing in the queue, then third, then 12, then maybe 23, something like that, 23 and 34. So, but I'm doing it from 1 digit, 2 digit, 4 digit, 5 digit. Okay, all of those are going in the queue. So that is an extra thing what been doing here, you know, because starting with the single digits, right? And then keep on pushing all 2 digit, 3 digit. If it was like a bigger one, in this case they say the maximum is 10 raised to 9, right? Yeah, so if you had something bigger, so you will keep on forming that big queue, but still it would be not that big, right? Because every number of digit max you can form like for first digit, one digit you'll form 10 numbers. For even
Two,
not
you
10, 9, right? Then it will be
9.
8, 7, 6, it will keep on decrementing. Yeah, so it won't be that huge also, right? Yeah, maybe
And
therefore it
this
is
is
working.
a good, you know, it kind of little tricky to see how the result it come out, it already sorted, right? Because of using the breadth first search, the BFS, put one in first and one have to come out first from the queue, right?
Yeah.
And then you keep append the number to it.
Yeah, you avoid sorting in this case. Yeah, that is one thing. That is right.
Because of BFS.
Yeah. But in the solution also, they have described a couple of different approaches, a sliding window approach, right? So that is also a good one. You guys have gone through that. So it is something like this, you know. So if you were given some number, what it says is you start with a number, okay, like this 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe a string like this, okay. And now you know what is your low, okay. Based on your low, if the low digits are 3, okay, you start with this number. This is a string, and then you just keep on moving this string of size 3 like this here, okay, then extract the number and then take this way, right? So this is also a very good way of doing it.
No,
You can do it.
but how will you take care of 4 digit if it is low and high?
Yeah, so you come to the end, so you are done with this, right? 7,
Okay.
8, 9. Then you go back again for the 4 digits.
Oh, okay.
Then you do like this. So that should also work.
He's highly optimized. Yeah. I mean,
Yeah,
and sorting
that's a
is
very good way. Yeah. So you keep on doing this till your you don't attain that high value, till you cross the high, and then you
So,
stop there.
so you check for each combination every time, right? I
Right.
mean,
Yeah.
so that would be high in complexity, right?
Why do you think so?
Like you'll be checking each combination for each of the number, like n kind of n square.
no,
No.
off and on, right?
Yeah.
He's sliding the window by K.
So here I'm not checking the combination. I'm actually getting the complete number as is described in the rules, right?
Oh, okay.
Yeah,
Right.
He's
because
leaving one number and taking the next number.
yeah.
Oh, okay. Okay.
So
But
I'm
how would you describe the time complexity? Because let's say you have like, you know, you could have like window from 1 to, let's say, you know, I want to start from low is 1 and high is, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9. What would be the runtime complexity?
So
Actually, the solution describes that as a O of 1. Saying
hmm,
he says the length of the sample string is 9 and the lengths of low and high are between 2 and 9. Hence, the nested loops are executed not more than 8 by 8, which is 64 times. That is what actually it's said in the.
91 times it should be, right? 81 times, right?
It
Because
says
first time you take
8. Uh,
single digit if you take, so 9 times you are running in first go, and 9 such.
yeah, maybe. Okay, if that is what you is the concern. But he was considering only from, I think, between 2 and 9. Yeah, maybe.
Yeah,
But yeah, the way they described, I like that implementation also.
that's a good one. Yeah.
Right.
Oh, hi. Yeah. He's my father, and
Okay.
Yeah.
So I'll just stop sharing. I don't have that implementation, but
no,
I thought of just sharing it.
Yeah. No problem. You can share it in Discord, like, yeah, later.
Okay, maybe I'll write the code and share it. No problem. I'll do that. Okay.
Yeah. So next, then we can go. So this,
Any questions on that? Any
yeah,
in your approach?
or any other approach.
Yeah. Okay. Let's move.
Okay. So next is like a reverse Polish notation we have to evaluate. So the value of arithmetic expression in this. So valid operators are plus, minus, star, and divide, and each of the operand may be an integer or another expression. And division between two integers should truncate towards 0, and the given RPN expression is always valid. That means the expression would always evaluate to a result where there won't be any divide by 0 operation. Okay. So this is your plus, right? So 2 plus 1, 3, and then ahead multiplication is there, whatever result we obtain, to that we multiply by 3.
Mm-hmm.
So like whatever you what you say operator, to back you take operands, do some operation over it, right?
Mm-hmm.
Like 13 and 5, you did some operation here, and then you'll return to a single number. After that, two operands are there and one operator, and you again do that and return the result.
So it is a postfix operations expressions,
Oh,
correct?
that's the correct term. Yeah.
Yeah. Yeah, I just went through that link what they have described in this problem, right? The reverse Polish notation.
Okay.
Yeah, because I was not knowing about it. So I think that has to be clarified, right? Or were you aware of that?
No, infix, postfix we have, right?
Right, right.
But here I just came to know when you told this.
Yeah, so the
Yeah.
reverse Polish notation, I was not aware that it is almost like a postfix expression.
oh, are you there?
But just when I went to that link, I saw that they mentioned it. Yeah. So
Yeah.
this is one thing we would have to clarify, because if this is a term I was not knowing, maybe some of you might know it.
Yeah,
I
try to
would surely
talk
get
and
it clarified, right?
did not then pick up.
Or we'll have to do it by ourselves, identify that, whether it's a postfix operation, prefix, or infix operation.
I want to know, is it
Mhm.
urgent or not?
By seeing this, because since
Something happened.
this is performed at last, so that's why it's a postfix.
Okay.
Had it been previous, then it will become prefix, and if it is in between, then it will become infix.
Yeah, right. Because if you look at the example, it is clear. But
Yeah.
when in an interview, they won't give an example, right? So you might have to write down the example and say, okay, if this is the way, then you'll have to write and make at least get a clarification saying it's a prefix or a postfix,
Yeah,
right?
that's
Something like that. So you'll have to uh, formulate some of your example in such a way that you understand it much better what is asking for, correct?
right. Yeah, that's
Okay. Because if you understand it's a postfix or a prefix, I'm not sure how the prefix implementation is, but if you know how the it's a postfix expression, it's easy to implement, right?
in that. Yeah.
Yeah. So understanding the pattern itself is might be a challenge there. So how to overcome it will be actually write down some examples and
In that
get
case.
a consensus on it. Yeah. Okay. So now if you know it's a postfix, so then what would be your
Then
thoughts on
you
that?
can draw an expression tree, right?
Hmm.
And
Okay. So you see, if you want to what you say implement or return a postfix expression, then you can do that, right? But you
using,
already are given a postfix expression, so it is very easy to evaluate. We just have to evaluate it, right? We don't have to create a postfix
okay,
expression.
yeah.
Yeah, so
Already
then
there.
it becomes easier. Yeah. Hmm.
Then again, two stacks. Either you use two stacks, right?
Okay. Hmm.
So like one will be your containing the operands, other will be your operator.
Hmm.
So you will push 4 as
Hmm.
long as you are not seeing anything 5, and then you'll have this, right? And now
Hmm.
you'll push when you, or even single stack should be enough, right? Whenever you hit this, you pop out these two things,
Hmm.
compute the operations, and then push it back to the stack. And
Hmm.
again, you saw the plus, you check these two operations, and then whatever result you get, you push it back to the stack, and once it is empty, return the last element of the stack. I mean, whatever is left in stack.
Yeah. Yeah. So we can do it with one stack. Yeah, that is true
Yeah.
because we just go through that input list of string. Yeah.
And, yeah. Or what should be another? This only, right? Almost.
I think other than the stack way, I don't.
Try. No, but why will it?
Sorry, what was it?
Try, I said. I don't think so. Try.
No, I don't think
Yeah.
because that's the only way I at least know about. Maybe after going through all these discussions, yeah, that's the only way it can be implemented. It looks like that, but if there is some other way, yeah.
So we use the stack. What would be the space and runtime complexity? Stack. You use two stack, right? Session.
Single stack.
Oh, single stack. Okay.
Yeah.
So yeah, the runtime will be just the number of input string,
Length of
correct?
your input.
Yeah,
Yeah.
and I don't think so. If space complexity will still be linear, right?
Mm-hmm.
Yeah, both of them should not exceed. Uh, yeah, but more than the runtime complexity and space complexity, we were just thinking loud. If there are another way of doing this. Stack is one way, at least we know most of
That
us
it's
know about this, right? Yeah. So is
whenever
there
it's
any other way to do it? Yeah.
mm,
This also looks pretty straightforward because it's just evaluating a postfix expression. Just use a stack the way Shashank described. Either use a two stack or a one stack, but I think one stack will be a better way of doing because the second stack is really not useful in this case, right?
yeah.
Yeah. So whenever we hit on any of these operators, so we just pop out two elements and that's all, and
Yeah.
then keep on pushing it back. So at the
Yeah.
end, whatever is the last element in the stack will be your answer. Yeah, this is pretty straightforward. Correct.
Yeah.
Okay.
Yeah.
So regarding the code, I think this only. Yeah. So this is my stack, and going through each of the tokens, and as long as, I mean, if it is a number, then only I'm putting it back to the stack, right?
Mm-hmm.
If it is operator, I won't do anything. Now I'll, oh, here two. Okay. Now two numbers will put right and left. We are popping, right?
Mm.
2 per 2. So if it is plus, do plus. If it is minus, do minus, append. If it is star, multiply and append. And if it is divide, do this. And at last return the, okay, pop. I mean, last one. It is like what I explained, the same thing.
Correct. Correct. So it's a integer division here. So therefore you are converting into float and again converting to integer.
Yeah.
Okay. So taking only the mm, non-fractional part of the value. Okay.
Value.
But if you don't put the float, cast to float, then what happened in Python?
It should work without float also, I think.
Because I think in Python that already floating division, right?
Yeah,
Integer
sure.
division.
It should work like that. Yeah, it's working.
Okay. Yep.
Yeah.
Yep. That's good. I think. Yeah. It's very clean solution.
Yeah.
Because in C++ you'll have to have a function for finding if it's an operator. Okay. And then keep on pushing that in a stack and then evaluate the way you're doing it here. Yeah.
In that case, yeah.
Yeah.
Yeah, in C++, it line number 8, it need more code, right? Need more line. Right, line number 8. Yes.
It's neatly implemented, so that's good.
Yeah. Then we can move to next, or
Yeah.
I think so.
so next. Yeah. So remove palindromic subsequences. So here it's already the string itself is a palindrome, so one removal itself will work. Now here, BB is a palindrome, right? So first this we remove, then you are left with A, and then A you remove. So two such removals.
Okay.
Yeah. Or what is doing? First is removing A and then BB. Okay. Yeah, that's also fine.
Can we read the problem statement?
Okay, sure. Yeah. So a string S is given, which consists of A and B, and in a single step you can remove one palindromic subsequence from S. You have to return the minimum number of steps to make the given string empty. And a string is a subsequence of definition of subsequence if it is generated by deleting some characters without changing its order. It's palindrome if it's in forward and backward string. So you have to make it empty in minimum number of steps, and you have to delete only palindromic subsequences.
Yeah. So the main thing is the string actually has only letters A and B.
Oh, okay, yeah.
It doesn't have anything other than A and B, correct? So that is one thing. So whatever subsequence and palindrome, that is one more. But it does have only A and B. That's very important. Yeah, and therefore, what Leon said, need to go through this problem statement very
Carefully, yeah.
carefully. Yep.
No, I didn't pay it. Like even I read it, I thought that it will be. So if it is more letters, it will be a bit more challenging, right?
It all depends, So, okay. So let's finish with this and then we can talk about that. Okay. So you are saying that you go through each and every time you take an input string and see if you can form a palindrome. If you can form a palindrome, you remove that substring and then move to the next one and then keep on counting your answer.
Yeah.
Okay. Yeah.
But, this is the subsequence, not substring palindrome, right?
Right.
Yeah,
Right.
So if you want to find the order, how if, let's say you find the order subsequence that begin with this index, then probably you go through the whole string, right?
Correct.
Yeah, you have to pass.
So if you want to find a substring, in case if we have only two letters, maybe it's a big string of 100, 200 letters, but all of the letters are only of two characters. So what are the subsequence going to be? So that is the question, right? So we'll have to ask always before implementing it, right? Yeah. Because when they say it's a subsequence, the problem is actually totally different, right? Then it's a palindrome. So it is a mix of both. Yeah. But if they don't tell you it's an easy problem and then they start with such a problem statement, it will be challenging to understand, right?
Yeah, I was like try going to find the other subsequence
Yeah,
that begin with this string. I mean, begin with this index. And
correct. So when they say it's only of A and B, then there are only two subsequences that you can form, whatever the way they are, right?
Yeah.
And every time any subsequence of that particular letter will always be a palindrome. Yeah.
but that you still need to check in. For example, in example 3, the BAAB is already a substring with as a palindrome, right?
Example 3.
Yeah, the first 4 characters is a palindrome.
Okay, but you still have another one, right? So you still have to spend two uh, counts in that, correct? So, but if you look at the example 1, I think, right, which is a complete palindrome, then that is a different case. So there you don't go and form different subsequence. You just use the palindrome. So I would say the first preference will be to give it to your palindrome. Okay, just look at your input string. If it's a palindrome, it's just one palindrome, just written one, right? Or else then you keep on forming different subsequences and then you return your answer.
But you want to form the longest subsequence so that you make the string empty early.
Yeah, that's true. So, but then even if you form a longer sequence, then it's going to be, the length is not a concern at all, right? In this case.
Yeah, just the number of times you make the string empty.
But we don't want to go there at all, because we just want to find if the string is, if a palindrome, then that is the only one, or if it is not, then your answer will be a fixed answer always, right?
Yeah.
Right.
That's
So, but the question what Shashank was saying, asking earlier. Oh yeah, someone actually posted in the chat, I think Paul. Yeah, could you speak out, Paul, if possible?
Yeah, no, this was a separate question just after. I was just doing, I kind of joined a bit late.
Okay.
So this is just another separate question. So I was just wondering how this string I posted in the chat gets reduced in a fixed number, which is 2. So this gets reduced in 2. So I was wondering how in 2 moves you can get to the empty string.
Yeah. So Leon, Shashank, do you want to answer this?
Yeah, let's go. Let me write on the screen, right?
You can just copy from the chat.
Okay. Let me see. I'll paste it here. Yeah. So this
So
is
how are
your
you going
one.
to make it? Yeah.
No, there is some constraint. Entire thing should also be a palindrome, right? Entire string. No.
No, that's correct. This input is perfectly right.
Yeah, so
See,
in the first one, you can actually make the substring BB, AA, B, and B.
well, see, you can make a subsequence of all A's first, and then second subsequence will be of all B's.
Yeah, it will be deleted.
Right, yeah, what Nick is saying, correct. So therefore, it will always be 2, no?
Yeah.
So,
All the A's and then.
Sorry, could you show it with the arrows?
okay.
I mean, like A.
Yeah, you take all the A's. How much A's are there in that? 6 A's, right?
One more A, right?
I think so, yeah. 1, 5, 6, and then all 4 B's. So these are your two subsequences, right? One is 6 A's and other is 4 B's. Therefore, you have two counts. And both of them are palindrome.
Yeah.
Got it. Yeah. Okay. Now I see what. Now
Yeah,
it makes a lot more sense.
right, right.
Like the other two problems were easier. This one stumped me because I misunderstood subsequence. Sorry.
Yeah,
Yeah.
yeah. No, that's fine. Yeah.
Yeah.
So
But
it's a very easy
if you
problem
do
that
with
way.
the substring, then that will be 3 operation, right? Because you have A, B, B, A, then A, then B, A, B.
Yeah, I was thinking substring instead of subsequence. Sorry, my
Yeah,
bad.
it's easy to confuse between both.
Right, right. So they have given both in this case, right? The subsequence and palindrome both together. Therefore, they're trying to confuse the user. Yeah, that's right.
Thank you so much.
Yeah, no problem. Yeah. So if you would had three of these letters A, B, C, Shashank. So in that case, that was your one more question, right? So at least the on the upper bound would always be three in that case also, right?
Number of unique letters. Okay.
Right. So either you form a palindrome, okay. So if you form a palindrome of your input string, that will be only one. Complete input string is a complete palindrome. Or if it is not, then either it can be two or it can be three. Correct. So there will be two options in it.
Yeah.
So if everything is unique, then O of number of unique letters, right?
Right. Yeah. The number of unique. Yeah.
And otherwise, I didn't get after that.
So
Just
see, if
after
your
one.
input itself is a palindrome, then it is one.
That
But
is one. Okay.
yeah, so if your input is not a palindrome, so then you can have either the answer will be two or the answer will be three. It cannot be more than three, right? So in this case, if it is A, B, C, it will be three,
Yeah.
right? But if you had something like a B in
Let's
front
say.
of A, B, C,
Okay.
okay, yeah, that also. So in this case, it will be two.
No, BB you will delete, and A and C three here also, right?
No, you can have a palindrome of BCB.
Okay. Yeah,
Yeah.
that
So you'll have to
palindrome.
find a longest palindrome in that case.
Let's
And
see.
if the rest of the string is not a palindrome, okay,
Yeah.
if it's not a palindrome, then it will always be three. In this case, you have two palindromes, BCB and A.
BCB. Yeah.
So you'll have to still go and do that palindrome for at least for the middle case. Okay.
Then again you go to DP, right? Longest palindromic subsequence. You get the longest palindrome first.
Yeah, so you'll have to do some amount of work in that.
Yeah.
But this problem is more easier. But that problem might be slightly trickier again. And then if they keep on adding one more letter to it, like a 4, then things will change, right?
Yeah.
So upper bound will always be 3, 4, whatever the way you are increasing. But to find the middle numbers, even though they are very few, but you still have to do some processing. I'm just thinking aloud, I don't know what it, but when you thought about when you said about it, I thought it might be an interesting problem also, because someone might pull us from this giving this input, or maybe this problem, they will surely pull us to some more extent, correct?
Yeah. No, I think you're saying correct only. You go to the middle and expand on both the sides and check uh, how long the extreme characters are same. So till the point you find they are same, you keep on going, and whenever it is different, you completely wipe out that those extreme points, right? So that is one cut, and again repeatedly you again find the middle.
Right.
Kind of, yeah.
So, but your count, if it is going more than 3, in this case, you'll have to stop, because it's going to be the maximum will be 3 always, right?
Yeah.
Yeah.
It
But
shouldn't
if
be
you
more
are
than
able,
number.
yeah, if you are able to find within 2, then it is good, or then you'll have to leave. But if they keep on increasing one more number every time, then things will be more challenging. Yeah. But the implementation wise, it will always be the same. You keep on looking for the upper bound till you don't hit an upper bound. You keep on form the palindromes, and then once you are done with the palindromes, but you'll have to always form a longest palindrome in that case, correct? Or maybe it will
Yeah,
be a
so
deep.
DP or expand around the center approach, which will be n square. I mean, take the middle and left and right will be on either side, and we keep on expanding that.
But this will be a subsequence, correct? So that will be
So
only
if
for verifying. So you'll still have to form all the subsequences and then find if it is a valid palindrome.
substring is a part of subsequence only, right?
Yeah, but if you are
Yeah.
if you form a subsequence, then you are able to delete the palindromes much quicker also, correct?
Compared to mhm.
So
That's
yeah,
what.
you might have to try both ways. I'm not saying that it's only the substring. Yeah, substring, if it works, that's fine. If it doesn't work, then you'll have to go and look for a subsequence also.
In that case, yeah.
So there might be some characters which are not in the substring, but they are still a palindrome for a subsequence. So
Then
you'll
you'll
have to
have to
check
go
both
for
of them.
the longest palindromic subsequence only.
Hmm.
From there you
Well,
check.
I'm just thinking loud. I don't
So
know,
it
but
looks
yeah,
like that
maybe,
only.
yeah. But that might be trickier. That is what I'm thinking.
Yeah, definitely. It will come under at least medium because
But will someone even ask a problem like that?
I mean, if time is left, yeah.
Yeah.
Depends. Yeah, but it's a good thought.
Yeah, but this question was really nice, even if it's easier one.
If they don't mention it is yeah, then it becomes like little bit
So there
tricky.
are some more pointers for us to actually think, or maybe just go through the problem statement very carefully and just think before even asking clarifying questions, right?
Yeah.
It's very important. Yeah.
It's like this is like a tricky question to me.
Yeah.
Not
Yeah,
really,
that's
right? It's just like
Okay.
so your same thing. If it is empty, we return 0 and we check if the reverse are equal, that is palindrome, then 1, it will do everything, otherwise return 2.
Okay. Yeah. So, but
so.
then you are
This
not checking a palindrome in this case, right? Okay. In that
No,
case.
line number 5 will check S and reverse of it.
Hmm.
If they are equal, then it's a palindrome.
so in this case, the space complexity would be big O of n because we have to reverse the string, right?
Yeah, it should be. Internally, it will take off in there.
But then, okay, yeah. So you could use a two-pointer approach for finding a palindrome instead of reversing and having an additional space.
Yeah.
And then you can actually reduce the space in that case.
But time will increase in that case, right?
Huh?
How?
Should it not be the same? Because you are starting from both the sides of the palindrome, the string, and the right and left, and keep on decreasing, and you stop at the middle. So same thing you will be doing here also, right? When you are reversing, you know that you don't even know. In this case, it will be more the time
Yeah.
because you'll have to compare to the end, both of them.
Yeah.
Yeah. Okay.
Yeah.
So
There was another problem with like kind of given a string and then we need to partition that string, and each partition should be a palindrome.
That's a hard one, I think, right?
Yeah, that's a hard one, right? And then each partition would be a long one because probably it should be the hard one. But it kind of like that a partition, but based on the substring, not the subsequence.
Subsequence, yeah. So that's again a backtracking problem. At every point you split and check if it is a palindrome or not, right? And then depending on that, you take the wise decisions. Should you backtrack or
But
What
you
do
have
you
to
feel?
keep track of like, yeah, I think you have to minimize the number of partition, right?
Yeah. Then it will be deep. Optimization is
Make
there,
it
right?
harder if you minimize it. If you want to minimize it, have you make like the partition, not only, sometimes the partition is long, but it give you, the overall, it might give you many partition. I mean, single partition might be long, but at the end, it might give you multiple partition. You don't like it, you have to, balance it out, because maybe the partition, you make it slow, but at the end, the number of partition is less, then that would be better.
So, but in that
Then
case, you will do. Oh, sorry. Go ahead.
LPS, longest palindromic substring you do, the
Yeah.
largest, what do you say, stream of characters, which is, because the larger the string, the lesser the number of partitions will be there, right?
Yeah, I agree. Yeah, that is
So
also
then,
what I was thinking about.
Hmm.
So you just
but
find the largest palindrome, correct?
yeah, substring, yeah.
Okay.
But then you'll have to start from both sides, left and right, or maybe just start from left side and then keep on reducing the right side one by one, and then find the longest palindrome, or you want to start from the middle.
No, I mean, every character, I'll take it as a, what you say, center, and then expand around center method. It will be n square only, like A, B, again, what you say, B is there. So initially, this I'll take as center, but there is nothing left, so I'll go here. But here A and B is not matching, I'll make this a center.
Mm-hmm.
So I'll keep on expanding and we'll see if they are palindrome, then I'll completely remove this. Then if non-palindromic strings are there, then again same thing. This will be a center and left, right, I'll check. So it will be n square only overall. Or you use then Manikers.
You need to, Sasha, you need to make the uh, empty
More than n
space, the
square, I think.
space
It's not
between
only n square.
as the middle. Because if you select one character at the middle, then you don't see palindrome in there, right? For example, if you get B, you say, okay, B is the middle, then there's no palindrome.
Yeah. So what are you telling? I mean, go to take the entire length of the string and hit the middle of that string.
Yeah, I'm saying you need to select the space, the empty space between B and B as at the center.
So he's saying
Okay.
you'll have odd number
Or yeah.
length of palindrome or even length. Yeah. Mm-hmm.
Then equally we'll expand both the
Yeah.
sides.
But we have a DP solution for this one, right? I think this is more than n square. It's not going to be n square, right?
No, expand around the center is n square only.
Well, you will have to
Because
do explore all the options, right?
every element you are taking as a center, right? So worst case will be what? You are at the mid and you are expanding here and this. So n length string you are expanding. Every time if you expand n on left and n by 2 on left, n by 2 on right, and n such centers are there. So it is O of n square only, right?
I'm not sure. We'll have to look
Because
at the problem, what actually he is referring to. But okay, yeah. Hmm.
because if this is your center, then n minus 1 string you have to expand. No, why n minus 1? I mean, you'll check this and you don't have anything. So you'll shift here. So only one string you checked in first iteration, two string in second iteration, then again three. So sum of n natural numbers and square. Or we'll have to check the exact precise
Because
result.
you'll have to even go and look for the palindrome, so that itself will be O of n when you want to
So
validate a
that
palindrome.
is on the fly only we are doing, right? The palindrome checking. Once you make this, let's say this is as a center. So if these two are equal, that means you are checking on the fly only. They are I mean, they will definitely form a palindrome. That's why you are expanding on left and right, rather than again checking, right?
Yeah, maybe we'll have to look at the problem statement,
Exactly. Yeah.
what exactly
That
is
will make
saying.
more sense.
Yeah, yeah. No problem. I think, yeah, we don't have anything to discuss now, right? So that's the only three problems we had. Okay. Do